Let's attempt computation of probability of a top event in which the basic events are connected by AND gate. I write here computation of probability P of T, which is equal to probability of A times probability of B. So, and I'm going to perform this calculation by Monte Carlo simulation, right? So, I import the library, import NumPy as NP, and well, I do not require this time matplotlib. So at first, I define probability of A, say 0.2, and probability of B is 0.3. And let's set the top event probability of T Monte Carlo, say it's 0, and we know that the probability of the top event theoretically it's equal to PA times PB, right? So from Monte Carlo point of view, we have to set the number of experiments, right? So I write here the number of experiments. Number of experiments, say 1000, right? And in 1000 experiment, I have to count the number of experiments with the desired success. So I say number of fails, number of top fails equal to 0, right? When both A and B are in failed state, our system is going to fail. That is the logic. So let's do it. So I write here for JJ in range n experiments, right? For several experiments, generate two random numbers. So let's define say x1 equal to 0 and x2 equal to 0. X1 for A and x2 for, okay, so let's set them xa, which means the state of component A and state of component B. I select these states randomly using the random number, right? So I say x of A. Okay, the indentation should be proper in Python. So x of A is equal to numpy random dot random. So one random number is generated for this one, and x of B is equal to numpy random dot random. So by this random, practically I mean state of component A, and by this one, I'm saying state of component B. Like we said, state head or tail. So now we have to see when both are in failed state, right? So I would say if x of A is less than or equal to PA, right? And x of B is less than or equal to PB, right? So this is the condition, right? Well, more clear structure. A and yes. So that was the indication that there is something wrong. The most of the programming languages are case sensitive. Generally, C-based programming languages are case sensitive. Fortran is not case sensitive. Why there is J, right? Okay. So with this one, this is the experiment in which we are going to experience a failure, right? So n fails would be equal to n fails plus 1, right? And that's it. This is the only condition. So we have to complete the loop and complete of experiments. Perform many experiments, right? So now the probability print. I say the probability. What was that? Well, first we have defined a variable probability of top event Monte Carlo that will be equal to n fails divided by n experiments, right? So let's write PT MC equal to PT MC. Well, it's a bad programming practice to use. Sometimes people get used to it, but using a combination of small letters and capital letters in a language which is case sensitive, I think that would be a difficult thing. And what's the value theoretical? Theoretical value is equal to, well, we already computed that. Theoretical, right? So that's it. Performing the experiments in this fashion. Import of library. With 1,000 experiments, Monte Carlo probability is close. However, to get even better results, let's add one more digit to accurate up to 2 decimal places, right? The power of Monte Carlo, right? So AND gate probability.